So good morning everyone. Very good morning to this session. I Manish Mishra. I welcome you all on this YouTube channel Unacademy GATE MEPIXE. So I can see already some of you are live. Sir, please product design and development facility design पढ़ा दीजिए for GATE PI. Arka, I will try. Okay. Actually, Arka, it is very simple. I mean, what you are asking me to teach, it's extremely simple. I mean, it will not take me 20 or 25 minutes, not more than that, to teach you that topic. Okay, so it is extremely simple. And yes, I will cover that. At the end of the module of industrial and OR, I will cover that. So, guys, good evening. Where is everyone? I have not received a single good evening today. What happened? Where is my entire team? I believe today all of them are busy with the UPSC AE solution and sir work sampling also my gate exam. Arka, I know when is the gate examination, and yes, I will be teaching work sampling. Don't worry about that. That is there in the syllabus. Avinash Yadav, Govinda Kumar, good evening. Good evening, Avinash. Good evening, Govinda. I mean, I have never seen you guys here in my live session. This is the first time I am seeing you all, even Arka. So, okay, then let us proceed. Good evening, Shivendra. Good evening. Okay, so let me proceed now. Let me proceed. So, for those who don't know me, my name is Manish Mishra. I secured an All India rank of 568 in GATE 2015. Good evening, Avnish. And I have a cumulative experience of 5 years in teaching. Good evening, Ashwin. I was thinking that what happened to Ashwin today. So, I have a cumulative experience of 5 years in teaching now, and the subjects that I primarily take are manufacturing science, industrial engineering, operations research, and material science. Okay, so guys, as promised, in today's session, I will be starting a completely new topic, and that topic, my friends, is linear programming problem. LPP. Okay. In the last class, we completed queuing model, and up until now, I have completed sequencing model, queuing model, project management, inventory models, forecasting, break-even analysis, line balancing. So these are the topics that we have already completed. And remember, guys, I have already made a video series on LPP transportation and assignment, which is available on the Unacademy app under the special class category. Okay, so remember, the special classes are absolutely free. Special classes are absolutely free. Just go check out my profile on the Unacademy app, and the entire LPP transportation and assignment is there. Okay, but then also I am going to start the series of LPP on YouTube because of the demand of the students. Sir, we have done LPP on Unacademy. Yes, Gaurav, but what to say, I have to cover the syllabus on both the platform. Okay, I did that because for one reason, there were several students who wanted the syllabus to get completed before time. I mean, they wanted to invest more time on industrial. That's why I created that module. Can I start industrial engineering from this topic? Absolutely, Crystal Roy. Absolutely. Then why are you doing these here? Gaurav, because I have a module and I have to cover that module. I mean, it's not like that I can skip these three on the YouTube. Yeah. I mean, I have allotted hours on YouTube. I have a schedule for YouTube as well as for the Unacademy special classes, and I have to fulfill both of them. Okay. When will you start material science, sir? Avinash, I don't know whether you have the that schedule for manufacturing 2020. Okay, I mean right now I am conducting a series on special class by the name Manufacturing 2020, in which I am going to cover the entire manufacturing with respect to gate examination in just 20 days time. Okay, so in 20 days time alone, I will be completing the entire manufacturing but for gate examination, and that too specially for gate 2021. So I have already provided the students with a schedule that these are the subjects, these are the topics that will be there, and I will be covering these topics, then that. So material science I believe is going to be on 27th or 28th of December. Okay. Sir, is there any difference in those and these? Gaurav, why there will be a difference? I mean, I have covered the entire LPP on the special classes, and I'm going to conduct those exact same thing here. I have told everything. I mean, the concept that I know, I have shared each and everything on the special class. So there is nothing new that is going to be here. Okay? The same thing. Is there any difference in those and these? Gaurav, the thing is that I have to make sure that I complete the playlist. Okay? I mean, these are my, what do you say, monthly goals that we faculties or the educators have to fulfill. So that's it. That's it. Let us just jump into the topic without wasting any time. So let us start linear programming problem. So guys, as Crystal Roy has asked me, Gaurav is asking, I mean, sir, in question. Let's see, Gaurav. I will be trying to add more questions, but then it will become very lengthy. So I think the question palette more or less will be same. Sir, you are really awesome. Merchant Circle is about 3 pages in normal note, but you made it in 1 page and easy to remember. Thank you, Ashwin. Thank you. I mean, that's the way I studied when I was preparing for GATE. The whole idea was that there were 10 subjects or almost 11 subjects, and to make sure that you study everything, you understand every concept, and then those 200 or 250 pages of notes of each subject, minimum 250 pages for each subject, then 12 subjects add up to about 1500 and 2500 or 3000 pages. It becomes almost impossible if you do not use these tricks to cut down on your notes, to make concise notes. You won't be able to succeed. I mean, this is the topper's strategy. I am saying this. Okay. So let us move on then. Let us start LPP, linear programming problem. So before we jump into this, let us first understand. That what is LPP. So as the name suggests, linear programming problem. ठीक है ना? So remember that all of us have studied linear problems when we were in 7th standard, or I think in 6th standard. That was the first time when the chapter got introduced to us as linear equations. That was the first time when this subject or topic came in existence for us. It became a reality for us in 7th standard. So what are basically linear problems? I mean, we all have studied a problem, an equation in which the variables has a degree of 1. That is basically a linear problem or a linear equation. ठीक है ना? Now, why we are studying linear programming problem here in engineering, and that too for an examination like GATE? The thing is, guys, if you will consider most of the problems that are out there, whether it is your day-to-day life problems, whether there are problems related to society, whether there are problems related to economy, whether there are problems related to any organization, any institution, any system, ठीक है ना? Whether it is real, virtual, anything. Out of those problems, if you would closely observe and use the mathematical know-how that you have, you will realize that almost 90% of those problems are basically linear problems. If you will convert a day-to-day life problem into a set of mathematical equation, you will notice that those equations are basically linear equations. Suppose, let me just consider one example. Just now, what was the name of that girl? Arka. Arka was saying that she is going to write the GATE examination on 14th of Feb. ठीक है ना? So she knows that what are the topics that are left out and what are the topics that she should cover before the examination. So she had all things set up for her. She's preparing herself for the GATE examination. But let us just consider this scenario. I mean, the GATE examination is going to be on the 14th of Feb, and up until then there are, like, let's say you have 2 or 3 subjects remaining which you have to cover in this moment of time. So now when I see that what you have is time as a resource. You have up to 14th Feb. The time that you have in your hands is up to 14th Feb, and in that time what you can do, you can just prepare. But the difference is there are going to be some students who will be utilizing this time in the most optimal way, in the best possible way they can, and they will be making the most out of this time. They will be benefiting the most out of this. And there will be some students who will just pass on this time, simply pass on this time. But there will be some who will make some strategy, who will make sure that they have the best of the strategy and they will execute that no matter what happens. No matter even if they don't sleep, they will execute that strategy. Okay, so in this situation, let's say the objective is that you want to excel in the GATE examination. In this entire scenario, the objective or the aim is that you want to excel in the GATE examination. You want to score as much as possible marks in the GATE examination. So right now I can say the objective of Arka is to maximize her GATE score. Now, if she wants to maximize her GATE score, she will have to utilize all the resources that she has, whether that is her time, energy, her study material, whatever she has, whether the Unacademy free classes or YouTube classes, anything, whatever the resources she has, she will have to make the best possible use of those resources. But then there will be certain things which will stop her in order to maximize her GATE score. There will be certain distractions out there which will try to stop her. So basically what I am trying to explain here is, whatever the situation we have, whatever the scenario we have, remember this thing, there is always some objective. When we have a problem, there is always some objective, and there are always some constraints. Or we can call them as restrictions, roadblocks, which stop us to achieve this objective, which stop us to achieve the maximum GATE score. And if we can just simply formulate this problem into set of equations, and we observe that those equations are linear equations, then by solving those linear equations, we can get a strategy, we can get a schedule, a plan. On following that plan, we can achieve this objective of maximizing our GATE score. So that is all that we are going to study in LPP. Okay, so let me just proceed and let me just write some few things so that you can copy that down in your notebooks. And yes guys, I will be writing everything down in LPP. ठीक है ना? Because number one thing, if I will make typed notes or typed PDF, if I will use that typed PDF, what will happen? There are so many little points which when you will write, ठीक है ना, I will be explaining those points while I am writing, and I will make sure that you also note down those points. So that guys, that will create a memory. If let's say there are 7 points in front of you on the screen and I just simply read those 7 points, explain that to you, it will be very difficult for you to recall those 7 points when you just revise the notes after my classes. So LPP transportation assignment, these 3 topics are such for which I am not going to make any pre-prepared PDF. I will not be using a pre-typed PDF to teach you guys LPP transportation and assignment. I will be writing down everything, and trust me, it will not take much time. It will not take much time, and it is important to write. Up until now, for those chapters for which a PDF would have worked, I have used PDF, and for those chapters a PDF could not work, I used my pen. Okay, so now for this I am going to do that same thing. Okay guys, so so now, what is a linear programming problem? First question is, what is LPP? What is a linear programming problem? ठीक है ना? If all the equations, if all the equations, that is the objective function and constraints are linear, then the problem is known as linear programming problem. Okay, a linear programming problem is formulated in two stages. Number one, objective function. Number two, constraints. Number one is objective function, number two is constraints. LPP consists of two stages. LPP consists of two stages. Number one, formulation of problem. Number two, finding out the optimal solution. Finding out the optimal solution. Optimal solution can be obtained by number one, graphical method, and number two, simplex method. Okay, so guys, now whatever I have written, I am going to explain that very thoroughly, because remember, ठीक है ना, in gate examination questions do come from LPP. ठीक है, let me tell you just this one thing straight away. This chapter LPP and then transportation and then assignment, they are extremely exhaustive, but not for me, for you guys. ठीक है ना, I just have to explain these things to you. I'll make sure I will do that in the best possible way, but it is going to be extremely exhaustive because I will make sure that you guys will solve question live on this class. Okay? So do not panic, nothing to fear. But remember, we will study this entire chapter in detail, considering each and every small concept which is out there, because in gate examination question do come and they do come from that deep part of concepts. Okay, so let me just explain this. Let me just explain this now. As I have explained you guys just before the start of this lecture, that okay, let me take some another route. सर बिट्स पिलानी एमटेक एग्जाम के लिए क्या लेवल होता है? Shivani, I think I should be teaching right now, taking this class. But if you have asked, let me answer that the level of the question is very easy. Okay? I mean, it is below the level of gate examination. So if you are preparing for gate, you will be easily covering that. So don't bother about that. Okay? So now let's focus. Let's focus. Suppose I take a scenario in which, let's say, a company make two products X and Y. Suppose a company, it make two products X and Y. There are two products the company is making. One is X, one is Y. Now to make these two products, the company need, no need to say Shivani, sorry, no need to say sorry. Okay. The company make two products X and Y, and for that the company uses two raw materials A and B. Okay, so the I am what I have said up until now, that the company make two products X and Y, and to make X and Y the company make use of two raw materials A and B. Now they say that to make 1 unit of X the company requires 1 unit of A and 1 unit of B, but to make 1 unit of Y they require 1 A and 2 units of B. Okay, so I hope up until this it is clear that the company makes two products X and Y. Let me just write products here. X and Y are the products, and A and B are the raw material. So let me just write raw material. Okay, so for 1 unit of X the company require 1 unit of A, 1 unit of B, and for 1 unit of Y the company requires 1 A and 2 B. Okay, now it says that by selling 1 unit of X the company makes a profit of 3 rupees. Suppose the company makes 1 unit of X and successfully sells it, then they make a profit of 3 rupees behind 1 unit of X. Similarly, they make a profit of 4 rupees behind 1 unit of Y. But one more thing is given in the question, that the availability of raw material per day, every day, the availability of raw material is restricted to only 450 units, and the availability of raw material B is restricted to 600 units per day. So I hope now you are getting the question. Okay, so the overall question is like this, that the company make two products X and Y with the help of raw material A and B, and these are the raw materials required in these ratio for making 1 X and 1 Y, and the profit on 1 unit of X is 3 and 1 unit of Y is 4, but the limitation is that every day we can have a maximum of 450 units of A and 600 units of B. Now this is the problem we have. This is the problem we have. Now what is basically the intention of this problem? The problem is basically asking what should be the number of X that we will be producing and what will be the number of Y we will be producing, so that we will be making maximum profit. So that we will be making maximum profit. So remember guys, in this situation the objective for the company is to make maximum profit. But in order to make maximum profit, the company will have to decide how much X the company should produce and how much Y the company should produce. I hope you all are getting my point. So now this is our problem. This is our problem. And now what I am going to do? What I am going to simply do is, I will write the mathematical equations respective to this problem. I will convert this problem into a set of mathematical equations, and that, my friend, is basically called as formulation. That, my friends, is basically called as formulation. Formulating the problem into set of equations. Okay, so how to do that? The number one thing that I am going to write is the objective function. The number one thing that I am going to write is the objective function. Objective function simply is the mathematical interpretation or the mathematical equation of our objective. ठीक है ना? So the objective that we have is that we want to maximize profit, and let's say profit is represented by z, then this equation will basically become 3x plus 4y. Now what is this 3x plus 4y? What is this 3x plus 4y? Guys, x represents the number of unit of x that we will be making, y represents the number of unit of y that we will be making, and as we are making 3 rupees profit on 1 unit of x, and let's say suppose I get the value of x as 100, then 3 into 100 means total profit from x will be equal to 300. So 3 rupees is the profit behind 1 unit of x, and 4 rupees is the profit behind 1 unit of y. I hope this is clear to you. I hope this is clear to you. Okay. So now this is what is called as the objective function. ठीक है ना? And the objective is to maximize this function. To maximize this function. So suppose somebody will tell me that this is the profit function, how much profit you can make? I would simply say I will make infinite amount of profit. Why? Because I can simply take the value of x and y to a upper limit of infinite. करोड़ों x and y बनाऊंगा, करोड़ों रुपए profit कमा लूंगा. But in this case I have certain restriction, certain limitations, and for that I am going to write a set of constraint equation. And for that I am going to write a set of constraints equation. Now what are constraints equation? These are basically the mathematical interpretations of the limitations that we have. Okay, so now let's check this out. Let's check this out. I am going to write one constraint. The constraint is x plus y less than equal to 450, and then I am going to write x plus 2y less than equal to 600. So what are these basically? I mean, if you will check out, 450 is what? 450 is basically the availability of raw material A. Now as I need 1 unit of A for 1 unit of X, 1 unit of A for 1 unit of Y, then the total X plus Y that I will produce cannot be more than 450. Because remember, if I have exactly 450 units of A, then the total X and total Y that I will make, that will require 1 unit of A for X, 1 unit of A for Y. That means if I only have 450 A, then total X plus total Y should be less than equal to 450. I hope you all are getting my point. I hope you all are getting my point. I hope you all are getting my point. So X plus Y should be less than equal to 450. X plus Y cannot be greater than 450. That is the constraint. Now, similarly, for Y, as you can see, for B, for 1 unit of X, I need 1 unit of B. And for 1 unit of Y, I need 2 units of B. And remember, I have only 600 units of B available. So I am writing 1 into X plus 2 into Y, that is the total B that is going to get utilized, and that cannot be more than 600. I hope you are getting my point. Now guys, you could ask one question at this moment. You people can ask one question at this moment, and that question is basically that when you are saying you want to maximize your profit, then the idea should be that we should make use of each and every unit of raw material we have. We should make use of each and every unit of raw material we have. That means utilizing A and B completely. But here I am writing that the total number of X plus Y can be less than equal to 450. The total number of x plus 2y can be less than equal to 600. So why I am writing less than? Why I am writing less than? That is my question. That why I am writing less than? So guys, check this out. Check this out. Okay. Suppose I see that 4 rupees is the profit behind 1 unit of y and 3 rupees is the profit behind 1 unit of x. Now I notice that y is more profitable than x. 1 unit of y is giving me 4 rupees. Keep x aside. Keep x aside, my friends. Simply make sure that you make y. Simply make sure that you make y. Suppose. So now if I go to make y, I know that for y, for every 1 unit of y, I need 1 unit of a, and for every 1 unit of y, I need 2 units of b. So if I will only consider the raw material a, then remember I have 450 units of a. And if I have 450 units of a with respect to raw material a, the y that we can make, the number of y's that we can make with respect to a is going to be 450 units. I hope you are getting my point. But remember, to make y, we not only need a, we need b also. And because for 1 unit of y, we need 2 units of b, and there are maximum 600 b available, then the maximum number of y that I can make with respect to b raw material is going to be 300 units. And remember, we need both A and B. And because after 300 units, B will get completely exhausted, that means I can never make 450 units of A. With the amount of raw material that I have, I can never ever make 450 units of A or Y. I hope you all are getting my point. I hope you all are getting my point. So guys, the maximum number of Y that we can make is 300 units. So guys, if I will make 300 units of Y, then 300 into 2, 600 units of B get completely exhausted, completely utilized. But if I will look at A, then for 300 units of Y, I will only utilize 300 units of A. That means 150 unit will remain behind. 150 units of A will remain unutilized if I decide to make Y completely. So guys, remember, there can be situations in case of a problem, in case of a linear problem, where sometimes you do not have to utilize all the raw material that you have. There could be a situation. I am not saying that this is the solution for this question. I am saying that there is a situation that some part of the raw material or some of the raw material might not get utilized, might remain behind while we are in a course to find the objective, to achieve the objective. So I hope guys this is clear to you. That's why I have written less than equal to 450 and less than equal to 600. Now I have one more constraint. And that constraint is that x and y are both greater than equal to 0. Why I am saying this? Because remember, x and y are products. Either I will make some units of x and y or I will not. That means x and y can either be positive or be 0, but they cannot be negative. Is it clear? Is it clear to everybody? I hope this is. Now guys, if you can see, I have formulated this entire problem that I have, this entire set of problem that I have completed the formulation, that I have basically written the mathematical equation of this problem. And you know what I have observed? In this problem, Number one, there is an objective function. Number two, there are constraints. Constraints are basically restrictions, roadblocks, which are stopping us, providing resistance to achieve that objective. And if you will simply see whether the objective function or any of the constraint, all these equations are basically linear equations. All these are basically linear equations, and that, my friend, makes this a linear programming problem. A linear programming problem. Now what we have written, let us just see this. A linear programming problem, when formulated, it has two stages. One is the objective function, one is the constraint. If all the equation, that is the objective function and constraints, are linear, then the problem is known as a linear programming problem. ठीक है ना? LPP consists of two stages. Number one is the formulation of problem, that we have already done. Now guys, once we have formulated the problem, the formulation of the problem is over. I have got the objective function, I have got the constraint. Now the second part is to find the optimal solution. To find the optimal solution, what does the word optimal mean? Optimal means, my friend, best possible. Best possible. Arey remember yaar, remember y equal to 300, x equal to 0 is one solution for this problem. I will be making some profit. What profit? 300 units of y, 0 unit of x. Let us simply put this in this equation. X equal to 0, y equal to 300. Profit will be 1200. So this is one possible solution for this problem. But my friends, it is not necessary an optimal solution, because an optimal solution is one which is the best possible solution, which is the maximum profit that I will be making by making some units of x and some unit of y. So remember, LPP can be solved in two stages. One, by the formulation of the problem into set of linear equation. Second, by finding the optimal solution. How to find the optimal solution? That is the question. The optimal solution can be obtained by two methods. One, the graphical method, one, the simplex method. And guys, from now on, from this moment onwards, I will be starting the graphical method. I will be first explaining you the graphical method. I will make sure that you guys get or understand the graphical method in the best possible way, and then I will go to the simplex method and explain why we are going to the simplex method. I hope you all are getting my point. I hope you all are getting my point. Let me just proceed. Let me just proceed. So this is our problem. This is our problem. And now I am going to solve this problem using the graphical method. So let me just write this problem here also in this new page. Otherwise the solution will be in this page. The question will be in the back page. That is not suitable. Okay. So basically the objective is to maximize profit. Maximize profit. Let us represent this by z. So this is basically 3x plus 4y. Then we have constraints. What are the constraints? X plus y less than equal to 450, x plus 2y less than equal to 600, and we have xy greater than equal to 0. Okay, so how to make use of the graphical method? How to make use of the graphical method? Let me just explain that to you guys. Okay, na? So guys, the number one thing that I will do, I'll make sure that every value is going to be in the first quadrant, because remember, both the variables that are there, x and y, they are greater than equal to 0. That means they are going to lie in the first quadrant. So let's say this is y and this is x. So at this point, my friends, I have basically drawn these two constraints. I have basically sketched the graph of these two constraints, because I have limited the value of x and y into the first quadrant. This is the first quadrant. Okay, the values are going to remain positive here. Now what you will do, just take out this equation, x plus y less than equal to 450. Remember guys, this is an inequality equation. Let me just write this equation in red color here. X plus y, let me just write this as equal to 450. Let me just put aside less than for a moment of time, and let me just sketch this line. So if x plus y is equal to 450, then keeping x 0 I get y as 450. Keeping x 0 I get y as 450. So this is the point 0, comma 450. And keeping y as 0 I get x as 450. So this is basically the point 450, comma 0. So let me just draw the line here. So this is the line, my friends. This is the line. Okay. Now remember, the original constraint equation was less than equal to 450. What I have drawn right now is x plus y equal to 450. Now I need to draw less than. So remember, when I say less than, then all the points that are there on this line, all the points that are there on this line are solution for this particular equation, but also all the points that are below this line in the first quadrant. Let me just mark that for you. In the first quadrant means this entire triangle here. Let me just shade this in yellow color for you. This entire triangle, the points that are lying on the boundary of this triangle as well as on the inside of this triangle, all the points are basically solutions, or I should say feasible solutions. Now before we proceed from here, I will have to make sure that you understand certain general terms. So this is general terms in LPP, because guys, from this moment onwards I will be making use of certain terms, and then I will expect that you guys know the meanings of those terms. So let us discuss those terms right now. It will take a very short amount of time, then we will go back to the solution part. Okay, so the number one thing is feasible solution. Feasible solution. What is a feasible solution? Let us understand. Any value of decision variable, which satisfies all the constraints, is a feasible solution. Okay, let me leave some space for example, because when I will be explaining this, I will be writing the example and I will be explaining this with the help of the example. Okay, then the next, my friends, is infeasible solution. So what is an infeasible solution? If the value of decision variable fails to satisfy even one of the constraints, then it is an infeasible solution. Again, leave some space for example. I will be coming back to this and explaining you guys. Okay, now the next term is optimal solution. If a feasible solution if a feasible solution for which the value of objective function decides the maximum or minimum, as the case given, is an optimal solution. Now there is one point, and you all should be writing this point in the form of a note, and that is optimal solution in a linear programming problem is always obtained at the vertex of the feasible region. At the vertex of the feasible region. So guys, I hope up until this point you guys have noted everything along with me and you are all up to date. Shall I proceed on? Shall I proceed with the explanation of these points? Come on, give me a yes or no. Give me a yes or no so that I can proceed. So now, the number one thing, what is a feasible solution? Guys, a feasible solution simply means a possible solution. Okay, suppose this is our set of equations. A feasible solution is one which will satisfy all the constraints. So when I say that x equal to 0, y equal to 0, is this a possible solution? A feasible solution for the problem? Let's find that out. So if I will keep x as 0, y as 0, I will get that as less than 450. So yes, that is a possibility. If I will keep x 0, y 0 here, again I have got the situation. And remember, x and y can be 0. So remember guys, x 0 and y 0 is satisfying both my constraints. So yes, it is a feasible solution. It is a feasible solution. Now if I will write x equal to 100, y equal to 200, is this a feasible solution? Is this a feasible solution? Let's find out. Keep x as 100, y as 200, I am getting less than 450. Keep x as 100, y as 200, I am again getting less than 600. So that ways x equal to 100, y equal to 200, x equal to 100, y equal to 200 is also a feasible solution. Now let us consider x equal to 200, y equal to 400. Is this a feasible solution? Is this a feasible solution? So if I will keep x equal to 200, y equal to 400, then 200 plus 400 is 600, which is greater than 450. So that cannot be the case. This constraint fails to satisfy. Again, keeping x as 200 here, y as 400 here, this constraint also fails. So remember my friends, x 200, y 400 fails to satisfy both the constraints, and it is a infeasible solution. Suppose I write x equal to 100 and y equal to 350. X equal to 100, y equal to 350. Now check this out. Keeping x as 100, y as 350, this constraint is getting satisfied. But again, keeping x as 100, y as 350, this constraint fails to satisfy. So remember, even if one of the constraints fails to satisfy, then my friends, that solution is basically called as an infeasible solution. Now, what is an optimal solution? An optimal solution, my friends, is that feasible solution for which the value of objective function decides the maximum or minimum. Remember, in this particular question, we can have a multiple feasible solution, n times of feasible solution, but our objective is to maximize the profit, and the solution at which the possible solution, the feasible solution which satisfies all the constraints on particularly that solution, if my objective is also achieved, that is I have maximized my profit, then I say that solution is called as an optimal solution. So basically at this particular point, my friends, we are doing all we can, that is by using the graphical method. By understanding the graphical method, then we will also understand the simplex method, just so that we can obtain an optimal solution for an LPP. Okay, now this is one point which is in note, and I will read this point, I will go through this point in a moment's time. Now let us go back to the solution that we were discussing. So guys, this is the solution that we were discussing. Now remember, x plus y is equal to 450 is one of the constraint. I have drawn the line. On this line, whatever the points that are there, every point will satisfy this line. And not only that, remember this is a less than equality sign. So all the points which are below this line, under this yellow region that I have shaded, that is in the first quadrant, in this very triangle, all the points that are inside this triangle or on this triangle are basically feasible solution for this particular line. So I hope you are able to understand what is the concept of feasible solutions and how we are getting feasible solution for an inequality constraint. Now I have another constraint, x plus 2y less than equal to 600. X plus 2y less than equal to 600. Keeping x as 0, I get y as 300. Keeping x as 0, I get y as 300. Can I watch this class after live with playback speed 1.5? Definitely, chess player. Why can't you? You can definitely watch this class. ठीक है ना? But I cannot be teaching at 1.5x speed. Otherwise, I think most of them would be able to understand. Okay. So now, keeping x as 0, I am getting y as 300, and keeping y as 0, I am getting x as 600. So let's say this point here is 600 y. So I will simply join this line. I will simply join this line just like that. But remember, this is a less than equal to sign. So less than equal to sign means that all the lines, all the points below this line are also valid. So let me just use blue color. So I am going to shade everything in blue color, and the area that I have shaded, with blue color, the triangle that I have shaded with blue color, this particular constraint, my friends, is having feasible solutions under this blue triangle. All the points that are on this triangle, whether on the boundary or inside this triangle, are basically the feasible solution for what? For this second number of constraint. Now let me use green color. Now what I am going to do, I am going to highlight the region. I am going to highlight that region, which is basically the common region, between both these lines, So this green region that I have marked, let me just mark the boundaries also, O, A, B and C. So this is 450 comma 0, remember guys, है ना? And what is this B point? Let me just calculate the value of B. How we will calculate the value of B? Because you can see that two lines are intersecting at this point. So I am just simply putting the values of these two lines, that is x plus y, 450, 600. So yes, this point B has coordinates x as 300, y as 150. I am using my good old calculator. I am using my good old scientific calculator. So guys, at this point, the region that I have shaded in green, that is the region OABC. This region, my friends, is called as the feasible region. Why this is called as the feasible region? Because remember, this is the common region that has feasible solutions for both these constraints. And remember, if I have the region which is full of feasible solution for both these constraints, this region is basically the region which contains the feasible solution for our entire problem. So I hope you all are getting my point. The region OABC is filled with all the feasible solutions, and now at least one of the feasible solution is going to be our optimal solution, which will achieve our objective, that is to maximize profit. So how to find that? Now let us go through this line. Optimal solution in a linear programming problem is always obtained at the vertex of the feasible region. What does this mean? Guys, it is simply saying that if you are looking for the optimal solution, you will find the optimal solution of a linear programming problem at the vertex. What is the vertex? Corner, my friends. Corner. Vertex means the corner of the feasible region. I hope you are getting my point. Neelaj has already answered the question. Don't worry, Neelaj. Let us first understand. Let us others also understand. Okay. So it says that the feasible solution will be obtained at either O, A, B or C. Out on these four corner points, four vertex points, one of the points holds the optimal solution. Now why? The question is why? Guys, suppose if I will look at this objective equation 3x plus 4y, then considering the constraints, the minimum profit that I can make is at x equal to 0 and y equal to 0, that is equal to 0. So this is the minimum profit that we can make. Under the constraints that we have, this is the minimum profit that we can make. So suppose I simply draw this line 3x plus 4y. So this line will basically look like, let's say, this. This line will look like this. So this line that I have drawn is basically 3x plus 4y. This line that I have drawn, this is 3x plus 4y equal to 0. Okay? It is passing through the origin also. Now what happens? Let's just see this. If I take this line and I start shifting this line inside this feasible region, if I take this line and I start shifting this line inside the feasible region, okay, you know what will happen? If I take this line inside the feasible region, the values of x and y will increase. Right now the values of x and y are such that the profit is equal to 0. But if I will shift this line inside the feasible region, let's say up to here, then at this point there is some value of x, at this point there is some value of y, and the profit will basically increase. But considering that I have to maximize the profit, then the idea is that we should be taking this line as far as possible. But remember my friends, the feasible solution is inside this green boundary only, is inside this green shaded region. Outside this green shaded region, you do not have any feasible solution. The feasible solution, that is the possible solution, is inside this green region, and the farthest that we can move in this green region is point A or point B or point C. So guys, remember the vertex points of the feasible region. That is A, B, C and O, they are the farthest point farthest point of the feasible region, and because the objective is to maximize here, I'll make sure that I check the values, of my objective function on A, B, C and O, which are basically the farthest points. Now if I will check the value at, let's say, O, that is 0 comma 0, so keeping 0 0 here, the profit will be 0. If I will check the value at A, let's say 0 comma 300, the profit is 4 into 300, that is 1200. If I have 300 comma 150, 300 comma 150, then x equal to 300 means 3 into 300 900 plus 4 into 150 600, that is total 1500. And at last let's check the value at C, that is 450 comma 0, so 3 into 450 is 1350. So you can see that this objective function of ours is getting maximized, at point B. So when this objective function passes through point B, that is 0 comma, that is 300 comma 150, we basically achieves the maximum profit, and that profit is 1500. And at this the value of x is 300, y is 150, that means we will be making 300 units of x and 150 units of y, and then we will making the maximum profit of 1500 rupees. So guys, this is the final optimal solution of this problem. This, my friends, is the final optimal solution of this particular problem, and I hope each and every one of you understood what I have done here. Each and every one of you have understood what I have done here. And guys, if you have any doubt up until this moment, feel free to ask me, because now I'm going to jump on to the next question, and basically you will be solving that question. You guys will be solving that question. I will be giving you guys a head start after writing that question. Okay, so let me move on. Okay, so the next question is a company produces two types of component. A company produces two types of component, X and Y, which requires operation on certain machines, comma, component X requires 12 minutes on lathe machine, comma, 4 minutes on milling machine, comma, 2 minutes on grinding machine. Y requires 6 minutes on lathe, comma, 10 minutes on milling, and 3 minutes on grinding machine. Profit earned on X and Y are 40 and 100 rupees maximum availability of lathe, comma, milling and grinding are 3000 minutes, comma, 2000 minutes and 900 minutes respectively. Determine the product mix for maximum profit. Product mix for maximum profit means that what should be the number of X and Y that we should be making so that we can make maximum profit. ठीक है ना? So in the question it has been given that company makes two products X and Y and they make 40 and 100 rupees by selling one X and one Y, that is the profit on X and Y. And now to make X and Y, the company requires three machines, a lathe machine, a milling machine and a grinding machine. So the respective times that the company requires on these three machines respectively for X and Y has been given to you, and it has been also given that these machines have a daily availability which is limited. So now with respective to all these constraints and for our objective to maximize profit, you have to find out the number of products that we should be making to make maximum profit. So guys, I am going to give you guys a head start of 2 minutes. Start solving this problem on your own. The first step is always remember to formulate this problem into set of linear equations and then solving that linear set of equations with the help of a graphical method and finding the optimal solution. So start doing that. I will be joining you guys within 2 minutes. Okay? I am giving you a head start. Guys, do one thing. Do one thing. Let me tell you something that this problem is very important. Don't even think for a second that it is just like the previous problem that we have discussed. I mean, this problem is special on its own, and I will show you guys that how this problem is special. But I have just checked that the time is over and I cannot continue this YouTube class anymore. So I will be summing this class up here at this very moment, and I would like all of you to solve this question on your own in your own sweet time. And tomorrow when I will see you all at 9:15 p.m. Tomorrow when I will see you all at 9:15 p.m. we will continue this lecture from here, from this very question. I will be solving this question. I will be solving this question. Okay, tomorrow at 9:15 p.m. at this very class. And guys, please make sure that you do attend this lecture, because let me promise you that this question is very important, although extremely easy. Although extremely easy, but then there is one point which is very important and I want to share that point with you, share that concept with you, which I will be going to do that at 9:15 p.m. tomorrow. Okay. So guys, that's it for today's session. That's it for today's session. Okay. Let me just tell you something, guys. The YouTube lecture and the special classes are there to titillate you, to make you realize that the level of content that is available on the Unacademy platform, the educators, the level of educators that is there on the Unacademy platform. So guys, if you feel like that you are benefiting from these YouTube free classes and the special classes, and if you want to have a full-fledged preparation, a preparation in which you have all the guidance, all the motivations available, all the tools available, ठीक है ना, so that you can have a competitive spirit in you and can prepare with that very competitive spirit. So guys, please remember, do make this investment. Go for the Unacademy Plus or for the Unacademy Iconic subscription, whichever you feel like. Please go and opt for these subscription packages. I mean, this is an investment, my friends. It will unfold it in future, ठीक है ना. Remember, via the Unacademy Plus subscription, you can not only watch unlimited number of live or free classes, you can watch different crash courses, you can give a weekly test. Every fourth class is going to be a doubt solving class. English and Hindi is not going to be a concern for you. There are different rank improvement batches available throughout the platform. And let me just share one thing with you. That on the Unacademy Plus platform, Evolve for GATE 2022, a completely new batch for GATE 2022 aspirants is starting on 28th of December. ठीक है ना? And this batch is going to be bilingual, that is both in English and Hindi. And this is specifically for mechanical students, and it is the first batch, that is the batch A for mechanical students. And you can see the legendary teachers, Aditya Gupta sir, Jitendra Gill sir, Praveen Kulkarni sir, Akash Tyagi sir, Rajiv Singh sir. These 5 top educators on the Unacademy platform are going to start this batch, that is the Evolve batch for GATE 2022. Guys, please make sure that you have the Unacademy Plus subscription before the starting or the commencement of this batch. If you will join this batch at the very starting, the concepts that you will be building one by one, climbing a ladder each and every step at once, guys, I promise that you all will be prepared, you all will be ready for the GATE 2022 examination, and you can simply crack that examination like anything. And remember guys, if you are going to opt for the Unacademy Plus subscription, you can use my referral code MMM10. This code can fetch you a discount of 10%. Instantly, you will get a discount of 10% across all the subscription packages, different permutation combination packages available on the Unacademy app. Okay, guys. So yes, that's that for today's session. If you have not followed me yet on the Unacademy app, please go check out my profile. This is my profile on the Unacademy app. There I am currently continuing a module on manufacturing by the name Manufacturing 2020. So if you will go and follow me on the Unacademy app, you can watch all my special classes absolutely for free. And remember to start your subscription for the free classes, or to unlock the sessions of free classes, you can use the code MMM10. Okay guys, and yes, this is my Telegram channel. Feel free to join this channel using this link. You will get the notes and PDFs of this lecture or my previous lectures on this Unacademy channel. I will be sharing all the practice booklets and contents on Telegram channel. So guys, that's all for today's session. Thank you all for watching this session. Please like, share and subscribe. I will see you all tomorrow in the morning at 9 a.m. on the Unacademy app, under the special class category, and then again at 9:15 p.m. on the YouTube channel live. So guys, up until then, bye bye. Thank you all for watching this session. I will see you guys tomorrow.